Hi, Ms. Torres. This is Danny, and this is the Chapter 2 test corrections. Okay, number 1, 3x over 2 minus 5x cubed quantity cubed. We would have to do the quotient rule, which would be low d high minus high d low over low squared. So 3 times 2 minus 5x cubed third minus 3 times 2 minus 5x cubed squared times negative 15x squared times 3x over 2 minus 5x cubed to the 6th. And we will try to get rid of this, so that would be 2 minus 5x cubed squared and 2 minus 5x cubed times 3 minus 3 times negative 15x squared 3x all over 2 minus 5x cubed to the 6th, and this would cancel and that would become a 4. So 2 minus 5x cubed times 3 minus 3 over times negative 15x squared 3x over 2 minus 5x cubed to the 4th. That would be 6 minus 15x cubed, and this would become 135x cubed all over 2 minus x cubed to the 4th, and this would become 6 plus 120x cubed over 2 minus 5x cubed to the 4th, and that would also be equal to 6 times 1 plus 20x cubed over 2 minus 5x cubed to the 4th. And for this one, c f of x equals to cosine x 2 cosine x plus 3 sine of x. For this one, we have to do product rule, which is the derivative of the first times the second plus derivative of the second times the first. So negative sine x times 2 cosine x plus 3 sine x plus negative 2 sine x plus 3 cosine x times cosine x. And with that, we would get negative 2 sine x cosine x minus 3 sine squared x minus 2 sine x cosine x plus 3 cosine squared x. And from that, we will get 3 cosine squared x minus 3 sine squared x minus 4 sine x cosine x, because we can combine the like terms, and we know that cosine 2x is cosine squared x minus sine squared x, so that would be 3 cosine 2x, and we also know that 2 sine x cosine x is sine 2x, so this would become negative 2 sine 2x. So 3 cosine x 2x minus 2 sine 2x is the answer. Problem number 1b. Y equals to x to the 5th square root of x squared plus 7. And we would do the product rule again. So 5x to the 4th times x squared plus 7 to the 1/2 plus 1/2 x squared plus 7 to negative half 2x times x to the 5th. And from that we get 5x to the 4th square root of x squared plus 7 plus 2x to the 6th over 2 square root of x squared plus 7. The 2's can cancel out, and we can also try to get a common denominator and get 5x to the 4th times x squared plus 7 plus x to the 6th over square root of x squared plus 7. And at this point we can distribute this and get 5x to the 6th plus 35x to the 4th plus 6x x to the 6th. X squared plus 7, and we can combine these two and get 6x to the 6th plus 35x to the 4th over square root of x squared plus 7. And this is also equal to x to the 4th, 6x squared plus 35 over square root of x squared plus 7. And problem number 2, a trough of length 14 and a height of 2 and a width of 5 feet is filled with water, and at height equals to 1 foot, they want to know what the change in height is. So as the water level rises, they want to know how fast is the water level rising when the water is 1 foot deep, and it is filled with water at a rate of 20 feet cubed per minute. So we know that dV dt is 20 feet cubed per minute. So from that we would need the volume formula, which is V equals to 1/2 base height times the length. And we know that the length doesn't change, so that would be 7 base times height equals to the volume. And the ratio of the base and height is 5/2, so 2b equals to 5h, so b equals to 5/2h. We can plug in b and get 7 times 5/2h squared, which is the same as 35/2h squared. And from that we can get the derivative with respect to time, so dv dt equals to 35/2 times 2h dh dt. And we know that dv dt equals to 20, and that the height is equal to 1, so we are able to find dh dt from there. And since these two cancel, 20/35 equals to dh dt. And thus dh dt equals to 4/7 feet per minute. And for number 3, write the equation of the tangent line to the curve y squared minus 4x cubed minus 30 equals to 2 at point 28. With this, we can get y squared equals to 4x cubed plus 32, which is y equals to square root of 4x cubed plus 32. And we can get the derivative of that by using the chain rule. So y prime equals to 1/2 4x cubed plus 32 times negative to the negative half times 12x squared. And from that we can get 6x squared over the square root of 4x cubed plus 32 as y prime. And we can plug in 2 for x and get 24 over square root of 64, which is the same as 24/8, and thus the slope is 3. And we can plug that into the point slope form, which is y minus 8 equals to 3 times x minus 2, which is y minus 8 equals 3x minus 6, y equals 3x plus 2. And now number 4, use the definition of a derivative to find dy dx for y equals to square root of 5x squared plus 13. We can recall that the definition of a derivative is limit as h approaches 0, f of x plus h minus f of x over h. And we can start plugging things in. Okay, from that, we have to try to get rid of the radical sign. So we know that multiplying by the reciprocal would get us that. So square root of 5x plus h squared plus 13 plus square root of 5x squared plus 13 on both the top and bottom. And that would give us 5x plus h squared plus 13 minus 5x squared plus 13. And with that, we will be getting 5 times x squared plus 2hx plus h squared plus 13 minus 5x squared plus 13. 13's cancel. 5x squared here cancels with that one, and we would end up with 10hx plus 5h squared on top. So that would give us h times 10x plus 5h over h times the square root of 5 times x plus h squared plus 13 plus the square root of 5x squared plus 13. And with that, h is cancelled, and we can also plug in 0 for h. So this would be cancelled out, and that would be gone. So we would get 10x over the square root of 5x squared plus 13 plus the square root of 5x squared plus 13, which is the same as 5x over square root of 5x squared plus 13. Number 5. Find the instantaneous rate of change of r with respect to x if r equals to 4x cubed plus 3 over 2x squared. Okay, instantaneous rate of change is just finding the derivative. So r would equal to 12x squared plus negative 3 x to the third, negative third. Since we know that this is the same as writing it out as 3 over 2 x to the negative 2, so that would give us the negative 3, and this would become a negative 3 here. So r would equal to 12x squared minus 3 over x cubed, which is the same as r equals to 4 x squared and 3 is in front minus 1 over x cubed. And that would be the final answer for that. Okay, so find the average rate of change of y equals to x cubed minus 4x squared plus 7x minus 1 on the interval of 3 to 8. And we would use the formula f of b minus f of a over b minus a. And when we plug 8 into this, we would get 311, and plugging in 3 would get 11. So that would be 300 over 5, which is the same as 60. Okay, for number 7, a ladder 17 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 14 feet per second. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 8 feet from the wall. So this would be x, this would be y, and x would equal 8. And we're trying to find this angle theta. And from this we can see that it's a special Pythagorean triangle. It is an 8, 15, 17 triangle. So y is 15. And to find the angle, we would use sine equal to theta, which is the opposite over the hypotenuse, which is x over 17. And from there we would do the derivative in terms of t. So that would be cosine theta d theta dt, and that would be 1 over 17 dx dt. And we can see that cosine theta is the same as 15 over 17 since it's adjacent over hypotenuse. So 15 over 17 d theta dt equals to 1 over 17, and dx dt we already know that it's 14, so this is 14, so 14 over 17 equals to d theta dt times 15, 17. And from that you can see that the 17 can cancel, and we're left with d theta dt equals to 14 over 15. And of course, this is radians per second. And a dynamite blast blows a heavy rock straight up with a launch velocity of 448 feet per second. It reaches a height of st equals to 448 t minus 16 t squared feet after t seconds where t is greater than or equal to 0. A. Find the velocity function. The velocity function is basically the derivative of this function. So it is 448 minus 32t, which is velocity. And for part B, what is the velocity of the rock when it is 2,560 feet above the ground on the way up? Okay, so for this one we would put 256 and set that equal to 448t minus 16t squared. And once we divide this by 16, we can get negative t squared, and for this we get 28t, and the last part we get 160. Okay, now what you can do is set this all onto one side. So t squared minus 28t minus 160, plus 160 equals to 0. So 160, negative 28, and negative 8, negative 20. So time can either be 8 seconds or it can also be 20 seconds. But we know that for the object to be at 2,560 feet, it has to be in a parabolic arc. So thus, it can be either here or in this part. So we know that since it starts from the left and goes to the right, this will be t equals to 0, and thus this is t equals to 8, and this is t equals to 20. So we know that at t equals to 8 is where the object is going upwards. So we would put that into the velocity function, which is 448 minus 32t equals velocity. So 448 minus 32 times 8 equals velocity. So that would be 448 minus 256 equals velocity, and that would be 192 feet per second. And for part C, when is the rock moving downwards? Okay, so whenever it is 0, the original function, when it's set to 0, then we know that the velocity is also 0, and it can either be a starting point or an ending point. So all we have to do is do 448t equals 16t squared, t's cancel, 16t equals to 448, thus t equals to 28, and as we know that in a parabola, the center is always where velocity is 0. So we know that at this part, the velocity is going upwards. This part, it is actually going back down to Earth. So we know that anywhere from the second half to the end is where the object is going to start falling. Thus, since 28 is the end point, we know that at this point it would be 14. So the rock is moving downward from the interval of 14 to 28.